resorted to only for arms and weapons, but as a matchless temple where I delight to be, to contemplate the beauty, the symmetry, and the magnificence of the structure, and to increase my awe and excite my devotion to the deity there preached and adored. And first, it seems not at all probable that if the omniscient author of nature knew that the study of his works did really tend to make men disbelieve his being or attributes, he would have given men so many invitations and almost necessities to study and contemplate the nature of his creatures. Of these invitations divers have been mentioned already, and more might be added to them, if we thought it requisite. And when with excellent microscopes I discern in otherwise invisible objects the inimitable subtlety of nature's curious workmanship, and when, in a word, by the help of anatomical knives and the light of chimical furnaces, I study the book of nature, and consult the glosses of Aristotle, Epicurus, Paracelsus, Harvey, Helmont, and other learned expositors of that instructive volume, I find myself oftentimes reduced to exclaim with the psalmist, "How manifold are thy works, O Lord! In wisdom hast thou made them all." and that this thing, at whatever cost, must be attained. You cannot hope to build a better world without improving the individuals. To that end, each of us must work for our own improvement, and at the same time share a general responsibility for all humanity, our particular duty being to aid those to whom we think can be most useful. I am among those who think that science has great beauty. A scientist in his laboratory is not only a technician, he is also a child placed before natural phenomena which impress him like a fairy tale. We should not allow it to be believed that all scientific progress can be reduced to mechanisms, machines, gearings, even though such machinery has its own beauty. We must not forget that when radium was discovered, no one knew that it would prove useful in hospitals. The work was one of pure science, and this is a proof that scientific work must not be considered from the point of view of the direct usefulness of it. It must be done for itself, for the beauty of science, and then there is always the chance that a scientific discovery may become like the radium, a benefit for humanity. Be resorted to only for arms and weapons, but as a matchless temple where I delight to be, to contemplate the beauty, the symmetry, and the magnificence of the structure, and to increase my awe, and excite my devotion to the deity there preached and adored. And first, it seems not at all probable that if the omniscient author of nature knew that the study of his works did really tend to make men disbelieve his being or attributes, he would have given men so many invitations, and almost necessities, to study and contemplate the nature of his creatures. Of these invitations divers have been mentioned already, and more might be added to them, if we thought it requisite. And when with excellent microscopes I discern in otherwise invisible objects the inimitable subtlety of nature's curious workmanship, and when, in a word, by the help of anatomical knives and the light of chimical furnaces, I study the book of nature, and consult the glosses of Aristotle, Epicurus, Paracelsus, Harvey, Helmont, and other learned expositors of that instructive volume, I find myself oftentimes reduced. The law of the conservation of energy is already known, viz., that the sum of all the energies of the universe, actual and potential, is unchangeable. A hypothetical theory is necessary, as a preliminary step, to reduce the expression of the phenomena to simplicity and order before it is possible to make any progress in framing an abstractive theory. Discrepancy between theory and practice, which in sound physical and mechanical science is a delusion, has a real existence in the minds of men, and that fallacy, though rejected by their judgments, continues to exert an influence over their acts. This law regarding the theoretical efficiency of heat engines by Mr. Joule, and the law of the maximum efficiency of heat engines, are particular cases of a general law which regulates all transformation of energy, and is the basis of the science of energetics. The laws of thermodynamics may be regarded as particular cases of more general laws, applicable to all such states of matter as constitute energy, or the capacity to perform work, which more general laws form the basis of the science of energetics, a science comprehending, as special branches, the theories of motion, heat, light, electricity, and all other physical phenomena. The words theory and practice are of Greek origin. They carry our thoughts back to the ancient philosophers by whom they were contrived, and by whom they were also contrasted and placed in opposition, as denoting two mutually conflicting and mutually inconsistent ideas. This fallacy, based on a double system of natural laws, retarded for centuries the development of physical science, notably mechanics. In thermodynamics as well as in other branches of molecular physics, the laws of phenomena have to a certain extent been anticipated, and their investigation facilitated, by the aid of hypotheses as to occult molecular structures and motions with which such phenomena are assumed to be connected. The hypothesis which has answered that purpose in the case of thermodynamics is called that of molecular vortices, or otherwise, the centrifugal theory of elasticity. The hypothesis of molecular vortices is defined to be that which assumes that each atom of matter consists of a nucleus or central point enveloped by an elastic atmosphere, which is retained in its position by attractive forces, and that the elasticity due to heat arises from the centrifugal force of those atmospheres revolving or oscillating about their nuclei or central points. According to this hypothesis, quantity of heat is the vis viva of the molecular revolutions or oscillations. It is possible to express the laws of thermodynamics in the form of independent principles, deduced by induction from the facts of observation and experiment, without reference to any hypothesis as to the occult molecular operations with which the sensible phenomena may be conceived to be connected, and that course will be followed in the body of the present treatise. But in giving a brief historical sketch of the progress of thermodynamics, the progress of the hypothesis of thermic molecular motions cannot be wholly separated from that of the purely inductive theory. He resorted to only for arms and weapons, but as a matchless temple where I delight to be, to contemplate the beauty, the symmetry, and the magnificence of the structure, and to increase my awe and excite my devotion to the deity there preached and adored. And first, it seems not at all probable that if the omniscient author of nature knew that the study of his works did really tend to make men disbelieve his being or attributes, he would have given men so many invitations and almost necessities to study and contemplate the nature of his creatures. Of these invitations divers have been mentioned already, and more might be added to them, if we thought it requisite. And when with excellent microscopes I discern in otherwise invisible objects the inimitable subtlety of nature's curious workmanship, and when, in a word, by the help of anatomical knives and the light of chimical furnaces, I study the book of nature, and consult the glosses of Aristotle, Epicurus, Paracelsus, Harvey, Helmont, and other learned expositors of that instructive volume, I find myself receiving a new truth is like adding a new sense. The secret of all those who make discoveries is that they regard nothing as impossible. A fact acquires its true and full value only through the idea which is developed from it. The more fodder, the more flesh, the more manure, the more grain. We may fairly judge of the commercial prosperity of a country from the amount of sulfuric acid it consumes. The loveliest theories are being overthrown by these damned experiments. It's no fun being a chemist anymore. The progress of mankind is due exclusively to the progress of natural sciences, not to morals, religion, or philosophy. From one sublime genius Newton more light has proceeded than the labor of 1,000 years preceding had been able to produce. In this apparatus is nothing new but its simplicity and thorough trustworthiness. On his revolutionary method of organic analysis. Chocolate is a perfect food, as wholesome as it is delicious, a beneficent restorer of exhausted power. It is the best friend of those engaged in literary pursuits. Chemistry, in its application to animals and vegetables, endeavors jointly with physiology to enlighten us respecting the mysterious processes and sources of organic life. If it is impossible to judge merit and guilt in the field of natural science, then it is not possible in any field, and historical research becomes an idle, empty activity. Observation is like a piece of glass, which, as a mirror, must be very smooth, and must be very carefully polished, in order that it may reflect the image pure and undistorted. If you want to become a chemist, you will have to ruin your health. If you don't ruin your health studying, you won't accomplish anything these days in chemistry. By the deficiency or absence of one necessary constituent, all the others being present, the soil is rendered barren for all those crops to the life of which that one constituent is indispensable. But it must not be forgotten that glass and porcelain were manufactured, stuffs dyed and metals separated from their ores by mere empirical processes of art, and without the guidance of correct scientific principles. A manure containing several ingredients acts in this wise. The effect of all of them in the soil accommodates itself to that one among them which, in comparison to the wants of the plant, is present in the smallest quantity. A time will come when fields will be manured with a solution of glass silicate of potash, with the ashes of burnt straw, and with the salts of phosphoric acid prepared in chemical manufactories, exactly as at present medicines are given for fever and goiter. I have spent some months in England, have seen an awful lot and learned little. England is not a land of science. There is only a widely practiced dilettantism. The chemists are ashamed to call themselves chemists because the pharmacists, who are despised, have assumed this name. Only about 70 years ago was chemistry, like a grain of seed from a ripe fruit, separated from the other physical sciences. With Black, Cavendish, and Priestley, its new era began. Medicine, pharmacy, and the useful arts had prepared the soil upon which this seed was to germinate and to flourish. I have learnt that all our theories are not truth itself, but resting places or stages on the way to the conquest of truth, and that we must be contented to have obtained for the strivers after truth such a resting place, which, if it is on a mountain, permits us to view the provinces already won and those still to be conquered. The finest imagination in the world could not have conceived of a better idea than the philosopher's stone to inspire the minds and faculties of men. Without it, chemistry would not be what it is today. In order to discover that no such thing as the philosopher's stone existed, it was necessary to ransack and analyze every substance known on earth. And in precisely this lay its miraculous influence. Without an acquaintance with chemistry, the statesman must remain a stranger to the true vital interests of the state, to the means of its organic development and improvement. The highest economic or material interests of a country, the increased and more profitable production of food for man and animals, are most closely linked with the advancement and diffusion of the natural sciences, especially of chemistry. Since the discovery of oxygen, the civilized world has undergone a revolution in manners and customs. The knowledge of the composition of the atmosphere, of the solid crust of the earth, of water, and of their influence upon the life of plants and animals, was linked to that discovery. The successful pursuit of innumerable trades and manufactures, the profitable separation of metals from their ores, also stand in the closest connection therewith. I would establish the conviction that chemistry, as an independent science, offers one of the most powerful means towards the attainment of a higher mental cultivation, that the study of chemistry is profitable, not only inasmuch as it promotes the material interests of mankind, but also because it furnishes us with insight into those wonders of creation which immediately surround us, and with which our existence, life, and development are most closely connected. Be resorted to only for arms and weapons, but as a matchless temple where I delight to be, to contemplate the beauty, the symmetry, and the magnificence of the structure, and to increase my awe and excite my devotion to the deity there preached and adored. And first, it seems not at all probable that if the omniscient author of nature knew that the study of his works did really tend to make men disbelieve his being or attributes, he would have given men so many invitations, and almost necessities, to study and contemplate the nature of his creatures. Of these invitations divers have been mentioned already, and more might be added to them, if we thought it requisite. And when with excellent microscopes I discern in otherwise invisible objects the inimitable subtlety of nature's curious workmanship, and when, in a word, by the help of anatomical knowledge, you must be ready to give up even the most attractive ideas when experiment shows them to be wrong. What is it possible to do well, in physics particularly, if things are not reduced to degrees and measures? Each metal has a certain power, which is different from metal to metal, of setting the electric fluid in motion. I continue coupling a plate of silver with one of zinc, and always in the same order, and place between each of these couples a moistened disc. I continue to form a column. If the column contains about 20 of these couples of metal, it will be capable of giving to the fingers several small shocks. Be resorted to only for arms and weapons, but as a matchless temple where I delight to be, to contemplate the beauty, the symmetry, and the magnificence of the structure, and to increase my awe, and excite my devotion to the deity there preached and adored. And first, it seems not at all probable that if the omniscient author of nature knew that the study of his works did really tend to make men disbelieve his being or attributes, he would have given men so many invitations and almost necessities to study and contemplate the nature of his creatures. Of these invitations divers have been mentioned already, and more might be added to them, if we thought it requisite. And when with excellent microscopes I discern in otherwise invisible objects the inimitable subtlety of nature's curious workmanship, and when, in a word, by the help of anatomical knives and the light of chimical furnaces, I study the book of nature, and consult the glosses of Aristotle, Epicurus, Paracelsus, nothing is ever too good to be true. I shall be with Christ, and that is enough. But still try, for who knows what is possible? Speculations, I have none. I am resting on certainties. A man who is certain he is right is almost sure to be wrong. I could trust a fact and always cross-question an assertion. The important thing is to know how to take all things quietly. The book of nature which we have to read is written by the finger of God. There's nothing quite as frightening as someone who knows they are right. Why will people go astray when they have this blessed book to guide them? Nothing is too wonderful to be true, if it be consistent with the laws of nature. Lectures which really teach will never be popular. Lectures which are popular will never really teach. I am no poet, but if you think for yourselves as I proceed, the facts will form a poem in your minds. All are sure in their days except the most wise. He is the wisest philosopher who holds his theory with some doubt. I have far more confidence in the one man who works mentally and bodily at a matter than in the 6 who merely talk about it. I can at any moment convert my time into money, but I do not require more of the latter than is sufficient for necessary purposes. Nature is our kindest friend and best critic in experimental science, if we only allow her intimations to fall unbiased on our minds. I happen to have discovered a direct relation between magnetism and light, also electricity and light, and the field it opens is so large and I think rich. It is right that we should stand by and act on our principles, but not right to hold them in obstinate blindness, or retain them when proved to be erroneous. Since peace is alone the gift of God, and as it is He who gives it, why should we be afraid? His unspeakable gift in His beloved Son is the ground of no doubtful hope. I am busy just now again on electromagnetism, and think I have got hold of a good thing but can't say. It may be a weed instead of a fish that, after all my labor, I may at last pull up. The philosopher should be a man willing to listen to every suggestion, but determined to judge for himself. He should not be a respecter of persons, but of things. Truth should be his primary object. I will simply express my strong belief that that point of self-education which consists in teaching the mind to resist its desires and inclinations, until they are proved to be right, is the most important of all, not only in things of natural philosophy, but in every department of daily life. I express a wish that you may, in your generation, be fit to compare to a candle, that you may, like it, shine as lights to those about you, that, in all your actions, you may justify the beauty of the taper by making your deeds honorable and effectual in the discharge of your duty to your fellow-men. Be resorted to only for arms and weapons, but as a matchless temple where I delight to be, to contemplate the beauty, the symmetry, and the magnificence of the structure. And this paper will no doubt be found interesting by those who take an interest in it. If I have succeeded better than many who surround me, it has been chiefly, may I say almost solely, from universal assiduity. No new creation or destruction of matter is within the reach of chemical agency. We might as well attempt to introduce a new planet into the solar system, or to annihilate one already in existence, as to create or destroy a particle of hydrogen. Matter, though divisible in an extreme degree, is nevertheless not infinitely divisible. That is, There must be some point beyond which we cannot go in the division of matter. I have chosen the word atom to signify these ultimate particles. I was introduced to Mr. Davy, who has rooms adjoining mine in the Royal Institution. He is a very agreeable and intelligent young man, and we have interesting conversation in an evening. The principal failing in his character as a philosopher is that he does not smoke. Berzelius' symbols are horrifying. A young student in chemistry might as soon learn Hebrew as make himself acquainted with them. They appear to me equally to perplex the adepts in science, to discourage the learner, as well as to cloud the beauty and simplicity of the atomic theory. We should scarcely be excused in concluding this essay without calling the reader's attention to the beneficent and wise laws established by the author of nature to provide for the various exigencies of the sublunary creation, and to make the several parts dependent upon each other, so as to form one well-regulated system or whole. The cause of rain is now, I consider, no longer an object of doubt. If two masses of air of unequal temperatures by the ordinary currents of the winds are intermixed, when saturated with vapor, a precipitation ensues. If the masses are under saturation, then less precipitation takes place, or none at all, according to the degree. Also, the warmer the air, the greater is the quantity of vapor precipitated in like circumstances. Hence the reason why rains are heavier in summer than in winter, and in warm countries than in cold.